All right, so 5.1 is pretty short. We'll knock that out, and then 8.5. And they both sort of go together. So 5.1 is nothing new. It's doing domain problems with fractional looking expressions. So let's see, this will be 5.1. Fractional expressions. All right, so the first thing we'll look at in this section is finding numbers that make a rational expression undefined. Remember, what makes a fraction undefined is if you get a 0 in that denominator, okay? So to find those numbers that make the rational expression undefined, we're going to take the denominator, just like y'all did on my test 1. So take the denominator and set equal to 0. And then any solutions to that make the function undefined. Okay, so any of them solutions would make it undefined. So here we go for this question. It says find the numbers for which the rational expression is not defined. All right, so let's see, these will be like 1 and 2. So for my number 1, I got 9b squared minus 10 over 14b plus 15. And I'm going to tell you a trick. The exponent on this b is not shown, so technically that exponent would be a 1. Since my highest exponent down there is a 1, I'm only going to get one number that makes it undefined. If I get squares down there, then I'm going to find 2 numbers on those, okay? So we just got the one number to worry about on that. So we're going to take that bottom, set it equal to 0. And then we'll solve that. So whatever answer we get will be the one number that makes it undefined, okay? So we basically want to get our b by itself. So I'm going to subtract that 15. And that'll give me the 14b equals a negative 15. Then we're going to come in and what, divide those times by 14. So that cancels and I get my b. Negative 15 over 14, we can't do nothing to that. So that don't simplify. So that'll be our final answer. So the only number that I would have to worry about if I was graphing that would be the negative 15 over 14, okay? So the first 2, you don't have to find domains or anything, just find those numbers. So let's try one with a square in it. So a y squared minus a y minus 4 over y squared minus 10y plus 24. So take that bottom, set it equal to 0. Don't want to factor that, but at that point, y'all got a quadratic formula in your calculator. If you did quad, it'd be a 1, negative 10, 24. Put that in quad, and it'll give you these two answers. I'm going to factor that, so both these will have a y. Both of these factors will be negative on the inside. So anytime the last number, the 24, is positive, both of these factors will have the same sign as that middle number. So since my key was negative, both of these are negative. Now, how many factors of 24 that'll add to get me a 10? 6 and 4. And all the rest of this is set them two little equations equal to 0 and get these signs changed. That's why I was sort of doing that linear factor stuff with you last week when you were doing the zeros. Because it's when you realize that the linear factors in the parentheses are always opposite than those answers. So that was negative 6, but when you solve it, you want to get a positive 6 and then a positive 4. So this one had the answer says the rational expression is not defined for y equals, and then you just put the 6 and the 4 and do that with it, okay? Then they still want me to find domains. So on these examples, I'm going to find the domain. But you know what's nice about domains is I find them the same way I found those numbers that made them undefined, okay? All right, so for number 3, we're given f of x equals 3x minus 7 over x plus 7. Now, they'll put these answers on some of them in both styles, so I'll use the set builder the first time. That's one where you had x such that x is not equal to whatever. And then I'm going to write them in interval notation using the parentheses, okay? So first, we need to set that bottom equal to 0. And we're going to solve that. So basically, I'm going to subtract a 7 from both sides. So now again, x is a negative 7. So the first answer will be set builder notation where they use the fancy looking parentheses. Oh, let me see what all they write out. So x is a real number. And x cannot equal negative 7. Okay. Then they want us to use interval notation. So from interval notation, you're going to start at negative infinity. Everybody's going to start at negative infinity on these problems. And then to kick out these numbers like that negative 7, we use what we call a union. So watch this. I go from negative infinity until I hit that negative 7. Now, we use curvy parentheses on the negative 7 because that means it don't include that negative 7. If I use the brackets, then the brackets would actually include that number, okay? So we go from negative infinity, we're unioning around negative 7, which is kicking it out of my domain. And then from negative 7, it heads off towards infinity. So on all y'all's answers, they will start with a negative infinity and a positive infinity. You just got to figure out what numbers we're kicking out. And this little union means and. So it's this domain plus this domain here, okay? The only number they kick out when they do the unions is that -7. So they're not too bad. Oh, I'm gonna do one like number 6. So this would be like all number 6. This one is a f of x. On top is an x to the third minus an x squared plus an x plus 3 all over x squared plus 11x plus 24. I got an x squared in this one, which means we will have 2 numbers that we're going to have to kick out of our domain, okay? So I'll let these big exponents sort of tell me how many of things I need. So I'm going to set that equal to 0. And y'all, I'm going to actually factor that one. But it's a x squared again, so you could use the quad. Anything that's an x squared in here, you can use the quad for, okay? All right, so that'd be an x and an x. 24 is positive, so both of these factors will have the same sign as that 11 in the middle. Now, this time I want factors of 24 that add to get 11. And that would be an 8 and a 3, okay? Now, quad would have spit out -8, -3, because it would have gave you the final answers on that, okay? So now, I'll set both these to 0. Subtract 8 on the first one. Subtract 3 on the second one. So I've got 2 numbers I'm going to kick out this time. And y'all, we still starting over here at negative. Oh, let me do the first part first. Let me think. I think that does it both ways too. And I guess all I'm going to do is set builder notation. So x such that x is a real number. And x cannot equal -8 and -3. Interval notation. You're starting at -infinity. So the question is, going left to right, which number would I hit first? That -8. So what we're going to do, we're going to union around that -8. So from -8, I'm cruising until I hit what number next? -3. So now we're going to union around that -3. So -3 union -3. So if you got 2 numbers, you will have 2 unions on this. And then from -3, I'm going towards positive infinity. Okay. So all real numbers in this section would be -infinity to infinity. And then we're just kicking out the ones we need, okay? So I will say the difference on these from my first test to this test. First test, all you had to do was this set builder notation, and you only had 1 number to kick out. Now, since y'all learned how to use the quad and factor and all that fun stuff, you can get 2 numbers out of these, okay? And then the The higher you go in math, the more stuff we kick out. We throw the cubes at you and the fours at you and everything else, okay? So 8.5 is rational functions. So it's basically 5.1 stuff with a few things added there. Okay. So if y'all ever heard of a asymptote, so I got two we're going to look at in here. The first one is a vertical asymptote. So someone like Mr. Newton or someone down the line come up with these names, okay? Well, Isaac Newton. A lot of stuff happens when you get hit in the head with apples, right? So a vertical asymptote is basically an imaginary vertical line that occurs where a function is undefined. They come in the form of x equals a number. A graph cannot cross a vertical asymptote. Okay, so have you ever seen graphs where one side sort of went up like that, and then this would be like an imaginary vertical line, and graph won't cross it. It'll go as close as it can get in both directions, okay? All right, so to find vertical asymptotes, we set the denominator equal to 0. And solve. Same thing we've been doing on all these problems. The reason y'all was finding numbers that made them undefined and then finding those domains was to get you ready for this one. Okay. All righty. Then we got a horizontal asymptotes. So these are technically like horizontal imaginary lines. That the graph tries to approach. As we head towards negative infinity or infinity. talking about the further you go out on these graphs, you'll see them trying to level off and get to one of these imaginary lines, okay? So there's three cases on the horizontals. So these are the three cases for horizontal asymptotes. Now, verticals were in the form of x equals a number. These horizontals will be y equals a number because it's a horizontal line, okay? I guess we can add that right over here. So these come in form y equals some number, okay? So verticals will be x equals, horizontals will be y equals. So the three cases of these horizontal asymptotes, and the three cases depend on the degrees of these polynomials. So the degree of the polynomial is basically the highest exponent, okay? So we're going to compare the degree of the top with the degree of the bottom. So if the top degree is greater than the bottom degree, so I got an x3 on top maybe and just an x on the bottom. If that's the case, there is no horizontal asymptote. Because what happens is the top is growing so much quicker than the bottom that they tend to head off towards infinity instead of trying to level out, okay? Second case, what if the bottom degree is bigger than the top degree? So if the bottom of your function is growing a lot quicker than the top of that function, then it wants to head off towards y equals 0. So over time, they're going to try to reach the x-axis. Never can get there, but they keep getting closer and closer and closer, okay? Then we got case number 3. Well, if the top bigger, the bottom bigger, what if they're equal? If the top degree equals the bottom degree, then it is y equals a over b. A is the lead coefficient on top. So the lead coefficient is whatever number's in front of that variable with the highest exponent. And B will be the lead coefficient of the bottom. So if they're equal, I'll look at what numbers are in front of the lead coefficients on top and bottom. And then that gives me the equation for the horizontal asymptote when they're equal, okay? Now, in the homework, when you're going to do some of these, sometimes they'll ask for an oblique asymptote. You're going to put, there's no oblique asymptote. Okay?
What is that?
It does like a angled one, but you're looking at when they equal each other. So we don't really mess with those ones. All right, so y'all ready? Start doing some of these examples. Here we go. Now, we'll say this. If you graph these in those calculators, if there's more than one part on top or bottom, you got to put them in parentheses. So like at the top of my fraction was an x squared plus 5. You better put that in parentheses, then hit the divide, and then put whatever's on the bottom. If you don't put them in parentheses, the calculator is not going to know what your top and bottoms are, okay? All right, so this example, they want me to list all asymptotes and graph. So first, when they say list all asymptotes, it's verticals and horizontals, okay? Oh, that won't work. All right, I guess I need that function is f of x equals 3 divided by x squared minus 64. So I will find the vertical asymptotes and the horizontal asymptotes. Now, if I want to graph it, I'll probably find my y-intercept. Okay? Because then that'll sort of tell me what's happening. Well, I'll show you when I get there. All right, so first let's find our vertical asymptote. From the vertical asymptote, I'm going to set the bottom of this fraction equal to 0. So x squared minus 64, I'm going to set equal to 0. I'll factor this, but if you use the quad on this, A is 1, B is 0, C would be negative 64. Okay? All right, so let's solve this by factoring. So there's an x and an x. Last number is negative, so you're going to have unlike signs in them factors. There's 0 x's in the middle, which means the middle number is a 0. What factors of 64 will give me a 0? 8 and 8, right? So this will be a plus 8 and a minus 8. And I'll tell you what, you're quick on that. But anytime you got something like this, take the square root of that 64. Or the square root of that 49 or whatever we got back there, okay? All right, so let's get this. I'm going to set both these equal to 0 now. And get my 2. So one of my vertical asymptotes is at negative 8. The other one's going to be at a positive 8. Remember, if you hit it with quad right here, it would have spit out 8 and negative 8. So I've got 2 vertical asymptotes. Now I'm going to find a horizontal asymptote. So the only thing I need to know for this horizontal asymptote is, do I got a higher degree on top or a higher degree on bottom? Bottom, because I got what, an x squared sitting down here? So the degree on bottom is a 2. Technically, the degree on top would be a 0. Okay? Because there's like an x to the 0 there, but remember, x to the 0 is 1, so we don't have to write on that. So you said the bottom was greater than the top, so the degree of the bottom greater than the degree of the top. So when that happens, I said this went to y equals 0. Okay, so I'm going to start graphing it, and then I'm going to show you why I'm going to need me a Y-intercept. All right, y'all, so let's see. Oh, I've got about 10, I guess. And then I don't care about going up. So, I've got some vertical lines. I'm going to put a -8 and 8 on the x's, okay? So over here at x equals -8, I got a vertical line going up and down. And then I got one of them over here at +8. Now, my graph will not physically cross those lines. It's going to get close and try to cross it, but it's going to shoot down or up, depending on which direction we go, okay? I got a horizontal asymptote, y equals 0. So that means as this graph goes towards infinity and negative infinity, it's going to want to try to get as close to that 0 as it can get eventually, okay? Now, I need to figure out which, am I up here or am I down here with my graph? Now, the zeros. Oh, we don't really know that. I'm just going to find what I call a y-intercept. So to find a y-intercept, you find it f of 0. Because you're putting the 0 in for the x, okay? So f of 0 is going to equal 3 divided by 0 squared minus 64. So that's what, a 3 over a -64. Now at that point, I'm happy because I just wanted to know whether that's going to be negative or positive. Now, zeros are where it crosses the x-axis at, right? So to find the zeros, you would take the numerator and set equal to 0. So here we go. I'm going to find zeros. The reason I'm doing that is because I'm trying to see if this thing's going to cross over this x-axis anywhere, okay? Because zeros is where I cross that, right? To find zeros, you set the numerator equal to 0. But y'all, I don't even have a variable on top, do I? So I would set 3 equal to 0, which is a false statement. This is false, which means there's no zeros. So therefore, no zeros. So I got enough to graph this. This -3 over 64, boy, it's just barely going to be under that x-axis, okay? But it's negative. And that's what we needed to know. Was it going to be positive or negative? Now check this out. If your graph is here, it cannot cross this line because we said there was no zeros. So the only choice this has is to come this way and shoot down. It's continue to get towards negative infinity. It'll get closer to that -8, but it's not going to touch that -8 because that graph would be undefined at that point, okay? Now, there's no zeros on this side, so this graph has no choice but to shoot down on that side. Now, if I'd have had zeros, then I might have went through the zeros and went upwards, okay? But since we didn't have no zeros, we didn't cross that line. Now, Asymptotes usually have a pattern. If one side comes down, the other side's going to shoot up. And guess what? As it goes to the left here, it's going to try to get to that 0, but it never can reach it, okay? So it just keeps getting closer and closer as you go to the left. And then the same thing here, right? It's going to come down, get close as it can, but never touch. Now, if I'd have graphed this one in my calculator, I would have put parentheses around that bottom, because you got 2 parts down there, okay? Now, they give you just pictures on this one to pick. So just go through and pick the one that looks right and be done, okay? Y'all get more used to this stuff. So that's why God made y'all a PI-84 with graph and power. Okay, so let's graph it and see. So I'll shoot it on my graph. So I'm going to share my new screen with y'all. So any of y'all been vaccinated? Me and you, the only ones, huh? So if they don't come next time, you don't gotta wear these hot masks. I don't think they can get us sick anyway, could they? So y'all can do whatever we just. All right, y'all. So let me get back on this.
I'm just sore, man. My body's sore. I spent the day on Saturday helping out something, everything is aching.
Oh man, lifting, a lot of lifting. Mm-hmm. All right, so I'm gonna graph this on the calculator. I'm gonna go to y equals. Just show you how I would put that in there. So the top only had a 3, so the top, I'm just gonna put my 3 and then divided by. Now the bottom's where I had more than one part, so the bottom's where I'm gonna put my parentheses definitely. So parentheses, and then that's what, x squared minus 64. And then I'm gonna close in parentheses. And really, I just want to get a general picture of that graph, so I'm gonna hit graph now. And that looks pretty close to what we drew up there, don't it? Theirs ended up being a little more squarish looking, I guess, but you know. So y'all get that? And that's a trick on those. Just make sure you're using parentheses on these kind of graphs, okay? You can also go to second graph and look at the table. And down here at 8, you got an error. And then if I went up to -8, you get an error. So errors means it's undefined at them spots, okay? So most of these, they'll just have pictures. They don't make you try to graph these things. Yeah, on all the ones where you got to do any kind of graph, and they got 4 pictures. All right, so I'm gonna. You get it?
No, mine was small.
Well, it's because y'all are. If the windows are pretty much set like mine. And you're just trying to make the asymptotes go down through there too. So you sort of still see what it's doing. For y'all, you would probably want to zoom out. Yeah, that zooms it out too far. So. Yeah, that's the main thing on that. That's blowing my mind. Probably these old pixels on these 83s. Let me see how yours do it. Yeah, see, he's got an 84, and it actually needs to be more of it. So the old 83s is this pixel thing on them, I guess. Oh, yeah. All right, y'all, let me get this back to the board. All right, so now they're just going to ask specifically for vertical asymptotes or horizontals. I'm going to find the vertical asymptotes. So we're just going to call them VAs now, okay? Is that cool? All right, so this starts at line number 5. F of x equals 1 divided by x minus 4 squared. So we don't have to graph these, I just want to find the vertical asymptotes. So to find the vertical asymptotes, I'm going to take that bottom, set it equal to 0. So x minus 4 squared, write that twice, right? X minus 4 times x minus 4 equals 0. Remember, do not foil that because then you're going the wrong direction. We just want to get answers out of that. Now, these are repeating factors. So I've only got to solve one of those since it's a repeating factor. Now, what happens since that's got an even exponent of a 2? It's not going to cross over the x-axis. It's going to come touch it and turn back up. Y'all have some questions like that on test 2 stuff. All right, so to solve that, I'm going to add 4 and be done. So you get x equals a positive 4. You got to write that as an equation, x equals 4 in that answer, okay? All right, 6 is f of x equals x minus 6 over x squared plus 5x. So take the bottom, set it equal to 0. At that point, if you want to use the quad on this, A is 1, B is 5, C is 0. Notice the difference. This one didn't have an X term long ago, so I made the B 0 on this one. This one has the X term, it don't have the number at the end. So that's why the C is 0 on that one. Oh, we're going to solve this by factoring. I'm going to factor out a GCF, which is the greatest common factor, because both of those have a what in them? An X. So you factor out the X. We're going to put the remainder in parentheses. So if you had an x squared, took out the x, left you 1x. And then the 5x, take out the x, leave you a 5. So watch this. Set this one equal to 0. Well, that was done. Y'all, a GCF, if it's the variable and you factor it out, 100% it's going to give you a 0. And then we said x plus 5 equals 0. Subtract 5 on that one. And get x is a negative 5. So this one would have 2 answers. Some of those will give you like an ABC answer and have them both. If you got to put them in, you got to put x equals 0, comma, negative 5, or you can write them both as a full equation, okay? But notice, exponent of 2 is what I found. two answers on that, okay? And y'all remember, y'all start taking classes tomorrow. Face-to-face will be only face-to-face. Hybrid or webinar will be only Zoom type stuff, and then online. We're not going to mix it up with face-to-face and online though, so if you're here Monday, you'll be here Wednesday, face-to-face, okay? They're having a lot of issues with attendance doing this back and forth stuff, you know? So y'all seen it's the same people all year, right? All right, let's see. I need another asymptote. Let me try one. Okay, I'll try this one. This one is like number 9. F of x equals x squared plus 3x minus 10 over x squared minus 5x minus 14. And by now, they're trying to throw a lot of stuff on top to make you play with the tops, but you're going to ignore it when you're finding a vertical asymptote. All I'm worried about is that bottom, so I'm going to set x squared minus 5x minus 14 equals 0. I'm actually going to factor that one. But it's the x squared, so y'all could use the quad on that, okay? All right, so I got an x and an x. That last number is negative, so these will have unlike signs. Can y'all find me factors of 14 that them two numbers will equal 5 when I subtract? So the 7 has to be negative like that middle, but that was my bigger number, and then my 2 will be the positive. All right, so let me set them to 0 to get these answers. So it looks like we'll get a negative 2. Oh, and a positive 7. All right, I guess I need a few of these with the horizontal asymptotes. Now remember, I had 3 cases for the horizontal asymptotes, right? So I'm going to do 1 case of each. So these examples are determine the horizontal asymptotes. So I'll do 11, 12, and 13. So 11 I have f of x equals 2x to the third plus 5, 3x to the third minus 5. So the degree on top is a 3. The degree on bottom is a 3. So the degree of the top equals the degree of the bottom. So in that case, I said y equaled a over b. A was the lead coefficient on top. B is the lead coefficient on the bottom. So what's the lead coefficient on top? 2. So that's this number right here. And then the lead coefficient on bottom is a
3.
So I get y equals a 2/3. Okay? So if they're equal, now remember, you just got to remember, if that 2 wasn't there, you better treat it like a 1 sitting in them places, okay? So Exponents equaled, I looked at those two numbers right there, okay? All right, let's see what 12 does. 12 has f of x equals x squared minus 4 over 7x to the 4th plus 2. So let's see, my degree on top is a 2, degree on bottom is a 4. So this time the bottom degree is greater than the top degree. So when the bottom was the greatest, we said this was y equals sort of like it, because the only one that really do any work is if they're equal. Then you're just looking at them numbers. The other two are pretty much either 0 or like this one I got for 13. Oh, that's a long one on top. Okay. So f of x equals x to the 3rd minus 5x squared plus an x minus 4 all over x squared minus 18. So I got a 3 on top, 2 on the bottom. So the top is greater than the bottom this time. So you only have one more choice. There is no horizontal asymptote. Good job. And I think they give you like a choice A or B on those. A would be if you had an asymptote, and then B, I think it probably says there is no horizontal asymptote. So we learned all of that so that we could graph one of these. So y'all watch this one. There's a lot of info on this. So find the domain. So I'm going to find the domain. Any asymptotes the x and y intercepts then graph. Now the reason they're hitting us with these x and y intercepts and all that is so we'll know which way to draw these asymptotes when we get to that point, okay? Oh, I guess I need the function is f of x equals 5x plus 2 all over my x. All right, so first, I want to find a domain. And let's see, the domain looks like interval notation with the infinities. So to find that domain, I'm going to take that bottom, which is the x, and set it equal to 0, which means the only number that I cannot have in the bottom of this is a 0. So let's see if y'all remember how I'm going to do that domain. I'm going to start way over here at negative infinity until I hit 0. At 0, I'm going to union around that 0. That's how I kick it out of my domain. And then from there, I'll head it off towards positive infinity. All right, then it says asymptotes. So I will start with my vertical asymptote. But don't I already got the work I needed for that? To find that vertical asymptote, all I was going to do was take the bottom of that and set it equal to, well, here it is. So my vertical asymptote is still going to be x equals 0. So I do like that about this. The domain and the verticals are going off the same work, basically. And I guess we did that to find the domains, okay? All right, what's the horizontal asymptote? So here's the question for the horizontal asymptote. You got a higher degree on top or a higher degree on bottom?
Are they equal?
They're equal. Good job, because both of these aren't x's. So the top equals the bottom. So it's going to be y equals what?
0. 0.
And they're equal this time, remember? I need that A over B ratio. But A over B is going to be a 5 over 1, which will just be a 5. So you just got to treat it like it's still got a 1 there, okay? So if they're equal, you look at the numbers. So that means as this graph goes towards these infinities, it's going to try to get to that 5 eventually, okay? X-intercepts. To find the x-intercepts, like I said a while ago, I forgot, but we set the top equal to 0. So the numerator would be 5x plus 2 equals 0. So pretty much everything I worry about that bottom on it, except for my x-intercepts, then I'm worried about that top. So y'all, I'll solve this by subtracting 2. So 5x equals -2. Then divide that by the 5. So that again, x is a -2/5. So that means the x-intercept is going to be a -2/5 and a 0. Ooh, let me make more room because then I got what? A y-intercept. So the y-intercepts. To find your y-intercepts, you're finding f of 0. Just like you're putting a 0 in for all the x's. So that would give me 5 times 0 plus 2 all over the 0 on the bottom. Oh, snap. What'd that do to me? I can't divide anything by a 0, can I? Which means there is no y-intercept. So this is undefined. So there is no y-intercept. That means this graph will not cross over that y-axis, okay? All right, so let's try to draw this.
Excuse me.
Okay, let me see. I had.
So you have a question.
Yeah, the screen's like frozen.
Oh, let me unshare and share again. It does that with this internet.
Oh, okay.
So
I like left and then came back. I was like, maybe it's my computer.
no, if it does that, just let me know and I'll unshare it and share it real quick back to you.
Oh, okay, thank you.
All right, so I should be moving around now, right?
Yes.
Okay. All right, so let's see. Verticals was at 0, so I don't have to go real far out here. So I'll just do 5s. My x and and my y. First of all, I got a vertical asymptote right on the y-axis at 0, right? Which means this is now an imaginary dotted line coming down through here. So I tried to make it like an imaginary dotted line. Mine is sort of fat so I can see the difference between the x-axis and the y-axis and stuff. But my graph will not cross over this line. The horizontal asymptote was y equals 5. So in the long run, at these 5s up here, my graph is going to try to get to that line eventually as it goes out, okay? So what else do I know? X-intercepts. Where is it going to cross the x-axis? It's going to cross at -2/5 and 0. -2/5 and 0 is almost to that 0, right? Not quite half of it, but 2/5. But it's negative. I needed that. Okay. So then I went and found a. Well, we knew there wasn't a y-intercept because it can't cross that y-axis at all. Okay. So remember, here's my horizontal asymptote, right? This is only going to cross this x-axis one time. So it's going to come up from here, hit that, and then it's going to try to curve up to that line. Okay. If this side of this asymptote is going down, this side is going to come from up here, but it's going to try to get to that eye on the top. Okay. Now, I knew this one couldn't come down because it can't cross the x-axis no more. Okay. So these asymptotes on the verticals, one side usually going to come down, the other side is going to try to go up. But they don't cross that. They get closer and closer as they head towards those infinities. And you can get within thousands, 10,000, 100,000 of that point, but it's still not going to touch that line, okay? Now, if I drew this in on my calculator, I would put parentheses around the top of that graph. Okay. So let me share and I'll show you what I would do on my calculator for that. So the 5x plus 2, I would put in parentheses. All right, so we put the top in parentheses, so parentheses, and then what, 5x plus 2? All right, close parentheses, and then divide by the 1x on the bottom. Now, it's going to be nice because the calculator is going to draw it a lot nicer than I did on there. But you still see the general picture. The only thing, remember, on the calculator, it's not going to show them lines. Them dotted lines are imaginary to it. But you do see how that almost in between that 0 and -1 is where that's shooting down. So that's what that -5 2/5 or whatever. And then they'll have 4 pictures of these. One will be right, the other ones will probably do all kinds of stuff too, okay? Did it do better on that one for y'all? It's just because that other one, I guess it's so small on them pixels or whatever. Let me try that again. Let me do that again. Hey, are y'all still seeing me online?
Yes.
Okay, because my TV in here went out on this. Okay, so, questions on those? So there's probably one more or two more at the end doing that. I'll probably do them at the beginning of next class. And then we're gonna knock out 8-6 is pretty easy. It's just doing inequality type stuff. It's shorter. This is one of the bigger homeworks. Because this had like 18 questions in it, I think. So in the last 3 or 4, we're doing that problem like I just did. We'll knock them out. There'll probably be 1 or 2 I'll do Wednesday, and then I'm gonna knock out 8.6, and that's everything for test 3. So we'll be finished with test 3 material this week. And then next week, start that last test material. So questions? Y'all getting close. Close to the end, right? Was this anyone's first semester? All y'all had been here before? Okay. First? Okay, you didn't go in the fall?
Oh, wait, I did, my bad, I was, sorry.
So all y'all went in the fall too then, right? Okay. All righty, so y'all all stop this.